Hello, this is AP Physics 1 Mass Practicum Fix-A-Post, and I will be redoing the work for this problem. So, to begin with, I have to first draw the free body diagrams of each of the masses. So, to begin with, I'll be drawing the free body diagram of mass 1. And we see that there are two forces acting on mass 1, which is the tension force and the gravity force. And they are both in the y-axis. So, I'll draw two forces in the y-axis, and I will label the top one force tension 1 and the bottom one mass 1 G to show as gravity. For our second mass, there are three forces acting. One of them is the gravity force, and the other two are the tension forces that are acting on an angle. So we will start with the first tension force, and we will label this force tension 1, same as on our first free body diagram, because as if you can look on the diagram, the rope connecting mass 1 and mass 2 is the same, and so the tension force will be the same as well. And then for our other force tension, this is a separate rope, so we can label this as a different force tension. We will say this is force tension 2, and then we have our gravity force. We'll label this as M2G. And then for our last free body diagram, it is similar to mass 1 in only that there are two forces, the tension force and the gravity force, and they're acting in the same y direction. So we'll draw two forces in the y direction, and the top force we'll label force tension 2, similar to the force tension 2 here, because the rope that's connecting mass 2 and mass 3 is the same and is acting basically the same as it is here and here, so it will be the same. And our gravity force will be M3G. M3G. Right, so now that I've finished drawing the free body diagrams for each of the masses, I can get to the part where I have to actually solve for the masses. And this is the part where I messed up on in the actual test. And the mistake I made was I basically did not know how to accurately derive the equations, so I just kept writing down random equations, not knowing what to do with them. So that was that was the reason I did poor on the test. So the correct way to do this would be, the first step I would take is to redraw the free body diagram for mass 2, but this time I will draw the component forces to help aid me in writing my force equations for when I get to mass 2. So I'll first redraw the free body diagram. And now I'll draw the component forces. So I'll start in the x direction. So since both forces are at an angle, they'll both have a force in the x direction. So we can draw two forces in the x direction acting opposite of each other. And we will label the angle as well. So the angle here will be theta 1 as shown in our diagram. And the angle here will be theta 2 as shown in our diagram. All right, and now the way we'll label these components is we'll use the sine and cosine functions. So in the case of these x components, we'll be using the cosine function, because if we were to draw the triangle with these forces, the force in the x direction would basically be the adjacent side of the triangle according to this angle. So, and the adjacent side is the cosine, basically. So this will basically be ft1 cosine theta 1. And similar to how we did on this side, we will also do the same thing on this side, except we have theta 2 and ft2, so it will be ft2 cosine theta 2. So now we've done our two forces and our two x component forces, we have to do our y component forces, and that will basically be sine components. So on the top we have ft1 sine theta 1. So and our other y component force is going to be ft2 sine theta 2. Right, so now that we've finished this free body diagram with our components, we can actually do the equations now. So we'll start with the equation for our mass 1, and we see that two forces are acting in the x direction, in the y direction I mean, and they are in equilibrium, so they will equal out to 0. So we will say that the sum of forces in the y direction for mass 1 is equal to Ft, force tension 1, because it's acting in the positive upward side. So minus M1G, because it's acting on the opposite side of Ft1. And that will equal to 0 because they're in equilibrium. If we manipulate this equation, we can see that force tension 1 is equal to M1G, and the way we do that is we subtract M1G on both sides, and we get that force tension 1 is equal to M1G. So we can, this equation here will prove useful for when we are solving for M2 and M3, because we can substitute in force tension 1 for M1G, because we don't know the exact value of force tension 1, but we do know the exact value for M1G because we have two knowns, M1 and G. So that will prove useful for solving for M2 and M3. So speaking of which, we will now solve M2, and since there are forces in both the x and y directions, we will have to be writing two equations for each respective direction. So we will start with the forces in the x direction. So the sum of forces in the x direction for mass 2 is equal to, and our two forces that we see in the x direction are ft1 cosine 1 and ft2 cosine 2. And we will say that ft2 cosine theta 2 is going to be in our positive direction, and we'll say vice versa for ft1 cosine theta 1. So we see that ft2 cosine theta 2 minus T1 cosine theta 1. And those will equal 0 because this whole system is in equilibrium. So if we do some algebraic manipulation and we subtract ft1 cosine theta 1 on both sides, we can see that these two forces are actually equal to each other. So we get is equal to ft1 cosine theta 1. And in this case, we want to solve for ft2 because that will be another reoccurring unknown that we can actually substitute with our knowns to find values for m2 and m3. And so to do that, we basically substitute ft1 with m1g, which we have over here, and we will divide both sides by cosine theta 2 so as to not only isolate ft2, but have it an equation equal to ft2 where ft2 is equal to all of our knowns. So we can simply substitute for whenever we have an ft2 in another equation. So once we do that, we see that ft2 is equal to m1g, which we substituted for ft1, times cosine theta 1 divided by cosine theta 2. So now that we've finished writing some of the forces in the x direction for mass 2, we will do the same for some of the forces in the y direction for mass 2. So we will start here, and sum of the forces in the y direction for mass 2 is equal to, and we see that there are three forces in the y direction: ft1 sine theta 1 and ft2 sine theta 2 will be in the positive y direction because they're acting upward, and m3g will be in the negative direction because it's acting opposite, downward basically. So we will write that ft1 sine theta 1 plus ft2 sine theta 2 minus m2g is equal to 0 because this whole system is in equilibrium. Let me correct this to m2g because this is gravity for mass 2. So after writing this equation down, we can we can add m2g to both sides, and we get that t1 sine theta 1 plus ft2 sine theta 2 is equal to m2g. Now we can we can divide both sides by g, and by doing that we'll isolate m2, so we'll have an equation for m2. So we'll have that force tension 1 theta 1 plus divided by gravity constant equal to m2, and we can substitute our force tensions for the equations here and here, and then we'll have an equation purely of our knowns. So final step for this equation is m1 g sine theta 1 plus m1g cosine theta 1 over cosine theta 2 times sine theta 2 all over g is equal to m2. So although this is quite the messy equation, we basically have an equation that is comprised all of our knowns, so we can easily solve by just plugging in for m2. And when we do that, and when we see that mass 1 is 0.200 kilograms from our given here, theta 1 is 30 degrees, and theta 2 is 45 degrees. When we substitute those values and that our gravity constant, we'll say 10, we can see that our mass 2, which I'll write down here, is equal to 0.273 kilograms. So that is the mass for mass 2. Now we will do mass 3, and we see here that the equation for mass 3 will comprise of two equations, ft1 and m3g. Not two equations, two forces, and they're both in the y direction and act opposite to each other and are in equilibrium. So our equation will look like this. Sum of the forces in the x direction for mass 3 is equal to ft2, because that is acting in the positive upward direction, minus m3g, because that is acting in the downward negative direction. And we will say this is equal to 0 because it is in equilibrium. Now if we add m3g to both sides, we see that ft2 is equal to m3g. Now we will substitute force tension 2 for this equation right here. And so now we get m1 g cosine theta 1 over cosine theta 2 equals m3g. Now to isolate m3, we will just divide both sides by g. And when you divide both sides by g, you're basically multiplying this side, the left-hand side, by 1 over g. And we see that there's a g in the numerator. So if I basically were to multiply both sides by 1 over g, which is essentially dividing them, firstly, the G here and the G here will cancel out. And the G here and the G here will cancel out. So we're left with M1 cosine theta 1 over cosine theta 2. That will equal M3. And if we substitute our knowns, which is mass 1 and theta 1 and theta 2, which I've already established, mass 1 is 0.200 kilograms and theta 1 is 30 degrees, theta 2 is 45 degrees. We find that our mass for mass 3 is going to be 0. So I'll write it here. Mass 3, 0.245 kilograms. So that is it for the mass practicum. That is how you're correctly supposed to do it. And yeah, that is it.